Hello friends, this is Vijayalakshmi. Welcome to Winman's YouTube channel. Here in this session, we will discuss the concept continuity and differentiability for second PUC. Here, this YouTube channel helping students across Karnataka to excel in their PUC board exam and competitive exam. Here, mainly in this session, we have to discuss the concept continuity and differentiability. Here, this chapter contains 17 marks for annual exam. Okay. First, we will discuss concept wise. Okay. The first concept is continuity and differentiability. Here, continuity and differentiability. Mainly, the concept containing continuity and discontinuity. Okay. Here, continuity and discontinuity. Continuity means we can draw a line without lifting a pen. Okay, here I am drawing a line. You can draw a line without lifting a pen, then it is called as continuity, or there is a continuously. Why? I can draw a line. Okay, here I can draw a line. Okay, these two lines are while lifting pen I can draw. Without lifting, I can't write these two lines. Okay, here there is a line without lifting. I can draw a continuous line. Here there is a two lines are there. They are not connected the endpoints here. Then it is called it as a discontinuity. Okay, based on the continuity and discontinuity, we have to solve the important 4 marks formula for in our annual exam. Okay, then after that, there is a next concept we will discuss here, that is basics of differentiability. We can solve the differentiability problems based on the chain rule, UV rule, and U by rule, U by V rule. That is called it as a question rule. Okay, these are the basic differentiability rules for solving the differentiation problems. Okay, then based on these rules, we have to solve the implicit functions, inverse trigonometric functions, exponential functions, logarithmic functions, and parametric functions. Okay, based on the chain rule, product rule, and quotient rule, we have to solve these type of functions. Okay, then after that, the very important concept here, that is second order differentiation. Okay, here for the second order differentiation, there is a 1 5 marks questions will be asked for your annual exam. Okay, this is the basic. Okay, the overall structure of the concept continuity and differentiability what we study. Okay, now we will start the concept. In this section, I will concept continuity. Okay, I will discuss the concept continuity. After that, in next session, we will discuss the differentiability, and based on the concept of chain rule, product rule, and quotient rule, we will discuss all the functions later. Okay, first here continuity, the basics definition of continuity. Here, suppose f is a real function. Already we know that the real functions. Okay, here in the real functions, there is a domain. Okay, f is said to be a real function, then domain and codomain both are real numbers. Okay, we have to define a function r tends to r, then it is called it as a real function. Okay, here the definition is suppose f is a real function on a subset of the real numbers, and let c be a point in the domain of f, then f is continuous at c if limit x tends to f of x is equals to f of c. This means here there is a domain. Okay, already we have studied. Okay, already we have studied the concept domain and codomain in functions. Okay, here there is a point. Okay, there is a point or number which is domain of f. Okay, here C be any point domain of f. Then here in this function we have to replace x by c. C means for any constant value which is present in a real number. Then we say that f is continuous at that point called it as c. On that point the function is said to be continuous. For example, I will solve a problem. How the continuity concept works. Here, let example consider a function f of x. Okay, f of x containing x square. Okay, is continuous at x is equals to, okay, here 2 represents the constant value c. Okay, then we take some condition that is called it as a limit x tends to c f of x. Now I can replace x by c. That is, it means the limit of x tends to c represents the condition of that function. Okay, condition for this function I can replace x by c. Okay, then what is f of x? That is x square. Limit x tends to c x square. Okay, here f of x is equals to x square, here x square. I will replace x by c, that is c square. What is means c? That is equals to function of c. Okay, here at x is equals to 2, I will replace limit. C means 2, f of 2. Okay, what is mean by 2? 2 is square, that is equals to 4. Okay, which is the real number. Okay, which is the real number present in a domain of function f, then it is called it as a continuous. Therefore, f is continuous. Then f is called it as a continuous. Okay, now again, based on the real numbers, we will discuss another one definition. That is, okay, we will define another one definition. Sometimes, okay, sometimes we will take the limits. That is, left-hand limit and right-hand limit. Okay, there is a point which is present here. The point C is present here. Here parts, okay, the points less than c, all the points are called it as a LHS part, and the values which is present, okay, after c, the values are taken as a RH. Okay, whatever the values we have to taken as a right hand limits. Some condition here, um, before the values of c we can call it as a LHR part. Based on these concepts, we will define the continuity definition if, okay, if limit, left hand limit, that is x tends to c minus for some less than c values. Okay, that is f of x is equals to limit of x tends to c plus f of x is equals to the main function limit x tends to c f of x. Okay, called that is f of c. All the values, that is the LHS part and RHL part, that is left hand limit, here right hand limit, and the main function. Okay, the main function all are equal means all the all the limit points all the limit point coincide at coincident to each other. Coincide. All the limit points are coincide, then it is continuous. Then it is continuous. Here this is the one of the main definition. Okay. Here this is the one of the main definition for continuity. Based on these definition of continuity, we will solve the 4 marks questions. Okay, in party. Okay, this is the main concept. Next, we will discuss the problems. First one problem. Check the continuity of the function f is given by f of x is equals to 2x plus 3 at x is equals to 1. Here, at point x is equals to 1. Now, first let us consider the function, that is f of x is equals to 2x plus 3 at point at x is equals to 1. Here, now the given function is of the type of polynomial function. Polynomial function means here the function f of x is of the form ax to the power n plus b x to the power n minus 1 plus c x to the power n minus 2 up to so. Then this type of problem is called it as a polynomial function. Okay, x must have a degree. Here the given function is polynomial because x having the degree x to the power 5. Okay, now check the condition at x is equals to 1. I will take the limit x tends to how much? 1. Okay, limit x tends to 1 f of x. Then limit x tends to 1. What is mean by the f of x? That is 2x plus 3. Now replace the 2x x by 1. That is 2 into 1 plus 3. What is the value? 2 into 1. 2 plus 3. That is equals to 5. That is limit x tends to 1 f of x is equals to 5. Again, we have to take direct value. That is f of 1 is equals to f of 1 is equals to f of 1 is equals to 2 into 1 plus 3. It is 2 plus 3. Okay, here limit from both. One is limit x tends to 1 f of x is equals to f of 5. That is called as f of 1. Here also f of 1 is equals to 5. Both are equal. Therefore, the function is continuous. The function is continuous at x is equals to. Okay, this is the solution of the given. Discuss the next example number 2. Discuss the continuity of the function f is given by f of x is equals to mod x at x is equals to 0. Okay, the given modulus function. That's why by the definition of modulus function, we written by the definition of modulus function. What we write? By the definition of modulus function, we can write f of x is equals to, okay, we can write f of x is equals to mod x if x is less than 0 and x if x is greater than 0. Okay, we can write now. But they given already. What is that? We clearly know that at point 0, okay, we clearly know that at point 0 and by the definition they are also given at x is equals to 0. Then we say that at x is equals to 0, then f of 0 is 0. Okay, now check the left hand limit. Now check the left hand limit, that is left hand limit x tends to 0 minus f of x. What is the f of x value? At x tends to 0 minus means we have to take the values less than 0. Okay, the function is x at less than 0 is minus x. So f of x will be minus x. Okay, then substitute the 0 in xy. Okay, here limit of x tends to 0 minus of minus 0 is 0. Again, similarly for right hand limit x tends to 0 plus f of x is equals to limit x tends to 0 plus f of x. What is the f of x? X. That is equals to 0. Okay. F of x, left hand limit and right hand limit. All the values are coincide at x is equals to 0. Okay. I am written here. Thus, the function f of x, left hand limit, right hand limit, all are coincide. Okay. All are coincide at x is equals to 0. Then the function is, okay, then the function is then the function is continuous. Okay, hence the modulus function, hence the function f of x is equals to mod x at x is equals to 0 is continuous. Okay, now this is clear. Okay, let's discuss the next example, that is example number 3. Okay, here example 3. Show that the given function, okay, show that the given function is given by f of x is equals to x cube plus 3 if x is not equals to 0 and 1 if x is 0 is not continuous at x is equals to 0. We have to show, okay, the function is not continuous. We have to show that the function is not continuous. First, we have to write the conditions roughly. Okay, here the function is continuous. Okay, when at point x is equals to 0, at x is equals to 0, at x is greater than 0 and the point x is less than 0. Here this is left hand limit, right hand limit and at function 0. At x is equals to 0. What is the function? That is 1. The function f of x is 1. At x is less than 0 and greater than 0. Not equals to 0 means it is less than and greater than point the function is. That is x cube plus 1. Here also the function x cube plus 1. Okay. We will solve now. Here the function is defined. Okay. Here the function is defined. Here the function is defined at x is equals to 0. Okay. Is 1. Okay. Because here they already given at x is equals to 0 the function is defined as f of x is 1. Then 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 we have to check now. At x is equals to 0 then f of 0 is equals to 1. Now let's consider the left hand. Okay, let's discuss the example number 3. Show that the function f is given by f of x is equals to x cube plus 3 if x not equals to 0, f of x is equals to 1 if x is equals to 0 is not a continuous at x is equals to 0. Mainly here in this function or in this question we have to prove or show that the function is not continuous. The function is not continuous at x is equals to 0. Okay. Here we observe the first question. Okay. F of x they given at x not equals to 0 and x is equals to 0. By the function let we draw a simple diagram at x is equals to 0, at x is less than 0 and x is greater than 0. It shows the left hand limit, right hand limit and this is the main function. Okay. This is just because of our understanding. Okay. Now let's discuss the function. Here, here the function, here the function f of x is equals to 1 at x is equals to 0. Now, they already given the function is defined. Okay. They already defined the function f of x is equals to 1. Now, check the left hand limit. Okay. As limit extends to 0 minus f of x is equals to limit extends to 0 minus. Okay, 0 minus means at the at point less than that of point x is less than 0 here. Okay, what is the value of the function? That is x cube plus 3. The function is x cube plus 3 is equals to, now let substitute the values. Limit extends to 0 minus, take x is 0, 0 cube plus 3 is equals to 3. Again, we consider the right hand limit. That is limit extends to 0 plus f of x. Okay. Here, limit extends to 0 plus. Okay. Then, what is the right hand limit? At x is greater than 0, therefore the function is x cube plus 3. Again, substitute limit extends to 0 plus, replace x by 0, that is 0 cube plus 3. That is 3. Here, here by the definition of here by the definition of continuity. Here by the definition of continuity, what we say, limit x tends to 0 minus f of x is equals to limit x tends to 0 plus, that is right hand limit f of x is not equals to the main function limit x tends to 0 f of x. Here the points right hand limit and left hand limit are coincide, but the main function is not coincident. That's why the function is not continuous. Here, since what we written, since the limit, since the limit of f, since the limit of f at x is at okay, limit of f at x is equals to 0 at x is equals to 0 does not coincident, does not coincident. That's why the given function is not continuous. Not continuous at x is equals to 0. Otherwise, it is called it as the function is discontinuity. Otherwise, we say that, otherwise, we say, otherwise, we say that the function is disconnectivity. Discontinuity. The function is discontinuity at x is equals to 0, which is the proof of the function f of x is equals to x cube plus 3 if x is not equals to 0, if f of x is equals to 1, if x is equals to 0 is not continuous at x is equals to 0. Okay. Now, let's discuss more on the next question. Let's discuss the questions one by one. Is the function f defined by f of x? If x is less than 1, the function is x. If x is greater than 1, the function is 5. Okay. Is continuous at x is equals to 0, at x is equals to 1, at x is equals to 2. Now, we check one by one. Okay. Here, at, okay. Here, at x is equals to 0. Okay. The function f of x is x. Here, the limit point. Okay. We don't have to check the limit point because at x is equals to 0, there is only one point because they given x is less than or is equals to 1 means the function holds the value f of x is equals to x. The function is f of x is equals to x. The function is polynomial function. The function is polynomial. Therefore, every polynomial function is every polynomial every polynomial every polynomial function is continuous. Therefore, at x is equals to 0, at x is equals to 0, the function is continuous. Similarly, at x is equals to 1. Okay, the given condition x is less than 1 or is equals to 1 and x is greater than 1. By the definition of the function, we draw roughly at x is equals to 1, then x is less than 1, here less than 1 and x is greater than 1. We have to check the limit points. Okay, the function defined, the function is defined at x is equals to 1. F of x is at x is equals to 1. F of x is what? That is x. Okay. F of x is equals to x. The function f of x is equals to 1. That is f of 1 is equals to 1 only. Again, for left hand limit, the function limit extends to 1 minus f of x. What is the function at less than 1? The function is limit. We can define f of x is less than 1, that is x. Okay. Again, substitute x value 1, then the function is 5. Again, we check the right hand limit. The limit extends to 1 plus limit. Okay, sorry. At f of x, here what is the at x is greater than 1, the value is 5. Okay, limit extends to 1 plus f of x is 5. So the value is 5. Here, just we checking the condition. I am writing here. Okay, that is limit extends to 1 minus f of x is equals to the left hand limit is equals to main function, that is limit extends to 1 f of x, but both values are not equals to right hand limit. Limit extends to 1 plus f of x. Okay, the left hand limit value will be 1. Here the function value 1 and but right hand limit will be 5. By this condition or by the definition, the function f of x is not continuous, at x is equals to 1. Similarly, we check at x is equals to 2. The function f of x is at x is greater than 2. It means the value greater than 1 also. F of x is equals to 5. Here the function is constant function. The function is constant function. The function is constant function. Therefore, every constant function is continuous. Every constant function is continuous. Therefore, we say the function is continuous. The function is continuous at x is equals to, okay, the problem is solved. Okay, next problem, that is, okay, here this is after this question number 2, all questions will be asked in examination. Okay, these are very important questions because I solved only some basics important questions only, because the continuity concept containing only definite 4 marks questions, that's why I concentrate on 4 marks questions only. So after these all questions will be very important for annual examination. Okay, the first question for 4 marks is, find the relationship between a and b so that the function f is defined by f of x is equals to ax plus 1 if x is less than or is equals to 3, bx plus 3 if x is greater than 3, is continuous at x is equals to 3. Okay, here we have to observe the function here. Okay, the function is, okay, the function f of x. Okay, here the function f of x, they given 2 points. Okay, is continuous. They only given the function is continuous. Okay. At point at x is equals to 3, we have to roughly draw. Okay. At x is equals to 3, what is the value? At x is equals to 3, the value is ax plus 1. At x is less than 3, okay, x is less than 3, the left hand limit, what is the value? Ax plus 1. At x is greater than 3, what is the value? Bx plus 3. Okay, this is the basic structure for solving the function. Okay, now we will solve the step by step. The first, okay, let the given function, let the given function f of x is equals to ax plus 1 if x is less than is or is equals to 3, bx plus 3 if x is greater than 3. Okay, now I'm directly checking the left hand limit, right hand limit and main function. Okay, because the function is continuous, that's why first left hand limit x tends to 3 minus f of x, that is equals to limit x tends to 3 minus, what is the value at x is less than 3, that is ax plus 1. Ax plus 1 is equals to, substitute x is equals to 3, the value is 3 into a plus 1. Again, similarly for checking right hand limit x tends to 3 plus f of x. Okay, here limit x tends to 3 plus, at x is greater than 3, what is the value? Bx plus 3. Bx plus 3. Okay, substitute x value 3. Then 3, 3b plus 3. Okay, here the function h at x is equals to 0. The function we defined f of x is equals to limit of x tends to x tends to 3, x tends to 3, f of x, limit x tends to 3. What is the f of x? The main function is at x, ax plus 3, ax plus 1. Substitute values, that is 3a plus 1. Okay. We know the definition by the definition of continuity. By the definition of continuity, what we say? Continuity, that is limit x tends to 3 plus f of x, right hand limit, left hand limit, x tends to 3 minus f of x, and the main function limit x tends to 3 f of x, all coincident, all coincident at x is equals to 3. Okay. By the definition of continuity, limit x tends to 3 plus f of x, limit x tends to 3 minus f of x, and limit x tends to 3 f of x, all coincident, all coincident at x is equals to 3. Then we say 3a plus 1 is equals to 3b plus 3 is equals to 3a plus 1. I will take these two, that is 3a plus 1 is equals to 3b plus 3. Okay. Now, we want the relationship between a and b. So, I can solve here 3a plus 1. Take plus 3 on this side. It becomes minus 3 is equals to 3b. Then 3a, 1 minus 3, that is minus 2 is equals to 3b. Okay. I will take 3 on this side. Then b is equals to 3a minus 2 divided by, I can take separately, that is 3a by 3 minus 2 by 3. I will cancel 3 by 3. Then b is equals to a minus 2 by, this is the relation for a and, okay, which is the relation, which is the, okay, which is the relation, which is the relation of a and, okay, hence b. Okay, fine. They given fine only. That's why, which is the relation of a and b. Up to this much, we have to solve. Which is the solution of the given problem. Okay. Now, discuss the example number 3. Okay. Third one. This question is also similar to that type. Okay. Find the value of k if the function f of x is equals to kx plus 1 if x is less than or is equals to 5, 3x minus 5 if x is greater than 5. Then the function is continuous at x is equals to 5. They are already given in the function. The function is continuous at x is equals to 5. Similarly, I can draw roughly, that is at x is equals to 5. Okay, at x is equals to 5, at x is less than 5, and x is greater than 5. Okay, what is the function values at x is equals to 5? That is equal symbol is there. That is ax plus 1. At x is less than 5, that is also ax plus 1. Here 3x minus 5. Okay. Now, let the function, let us consider the function f of x is equals to kx plus 1 If x is less than or is equals to 5, then 3x minus 5 if x is greater than 5. Okay. Now we will check the left hand limit, right hand limit and the main function. Now I will solve the left hand limit now. The left hand limit x tends to 5 minus. Okay. Here they given 5. 5 minus f of x is equals to limit x tends to 5 minus f of x. Here at x is minus less than 5 means the function is kx plus 3. Kx plus 1. Substitute x by 5, that is 5k plus 1. Similarly for right hand limit x tends to 5 plus f of x is equals to limit x tends to 5 plus at x is greater than 5, then the function is 3x minus 5 is equals to substitute x by 5, that is 3 into 5 minus 5. Okay, that is 3 into 5, 15. 15 minus 5 is equals to 10. The value 10. Again, by the definition, at x is equals to 5, the function we defined f of x, that is limit x tends to 5, f of x is equals to limit x tends to 5. What is the function? That is kx plus 1. Again, substitute the values x by 5, that is 5k plus 5. Now, by the definition of continuity, we say left hand limit x tends to 5 minus f of x is equals to right hand limit x tends to 5 plus f of x. Then the function limit x tends to 5 f of x. Okay, all are coincide each other. All are coincident at x is equals to 5. All functions are coincident at x is equals to 5. We say 5k plus 1 is equals to 10 is equals to 5k plus 1. I will take only these two. Then 5k plus 1 is equals to 10. 5k is equals to, take plus 1 on right side, it becomes minus 10 minus 1. 5k is equals to 9. K becomes 9 by 5. Okay. Therefore, the value of k is 9 by 5. At x is equals to 5. K is equals to 9 by 5. Okay. Up to this much you have to solve for 4 marks. Okay. Let's discuss the next one problem. This is also one of the very important formula. Okay. Now, determine the value of k if the function f of x is equals to k into cos x divided by pi minus 2x. If x is not equals to pi by 2, f of x is equals to 3. At x is equals to pi by 2 is continuous at x is pi by 2. Okay, here the function is also continuous at x is equals to 2. Again, we solve the problem. Let's consider the function. Okay, let consider the function f of x is equals to k into cos x divided by pi minus 2x at x is not equals to pi by 2 and 3 at x is equals to pi by. Okay, here again we roughly take the values here. At x is equals to pi by 2, the value will be at x is equals to 5 by 2, the value is 3. Similarly, at x is less than pi by 2 and x is greater than 5 by 2. At x is less than pi by 2 and x is greater than 5 by 2, we will define. Okay, now we define the left hand limit. Limit at x is equals to pi by 2 minus f of x. Okay, here limit x tends to pi by 2 minus, what is the f of x? X not equals to 0, that is k into cos x divided by pi minus 2x. Okay, again substitute the pi by 2 value in place of x, that is k into cos of pi by 2 divided by, okay, pi minus 2 into pi by, okay, next k into cos pi by 2, it can be written as, okay, it can be written as, first I am writing similar, then I will change pi by 2 divided by pi minus, here 2 get cancelled, pi minus pi, okay, this is of the form 0 by 0, okay, this is of the form cos pi by 2 value, direct we apply the limit cos pi by 2 value, then it is 0, again pi by 0, 0 by 0, okay, we can't define the function, we can't define the function here, okay, now I use L hospital rule. L hospital rule. What is mean by the L hospital rule? Okay, here we discuss the L hospital rule when we consider two function. Okay, when we consider two function, we consider the function when consider the function of the form limit x tends to 0 of f of x divided by g of x. Okay, if we substitute directly x by 0, then the function tends to 0 by 0 or 0 by infinity or infinity by infinity. These forms are called as a indefinite forms. These are called as a indefinite forms. Then in this type we can't define any function. That's why we have to differentiate. Okay, we can differentiate the above function. Okay, on that again differentiate separately. Okay, here differentiate f of x separately and again differentiate g of x separately. Now I use the hospital rule. After that we have to use the limit values. Okay, here I am taking limit x tends to pi by 2 minus Okay. Here, if I apply limit directly, then we can't define function. That's why I differentiate the function separately. Okay, here k is constant. Differentiation of cos x will be minus sin x. Differentiation of cos x will be minus sin x divided by pi is the constant values. Differentiation of minus 2x again minus 2. Okay, then I apply the limit. Limit x tends to pi by 2 minus k into minus of x by pi by 2 divided by minus 2. Here, sin pi by 2 will be 1. That is minus k. Minus of sin pi by 2 value 1. Minus of k divided by minus 2. Minus minus get cancelled. The value becomes k by 2. Okay. Again, I will erase here because I have place for solving the next step. Okay. Now the left hand limit will be k by 2. Again, I will take the right hand limit. Limit extends to pi by 2 plus, okay, f of x, that is equals to limit at x is equals to pi by 2 minus x is not equals to 0. Similarly, that is k into cos. Next one problem. Find the value of k so that the function f is continuous at the indicated point. Okay. Here, the function f of x, 2x plus 1, if x is less than or is equals to pi, the function f of x is equals to cos x if x is greater than pi at x is equals to pi. Now, let's solve. Okay, let us consider the function. Let us consider the function f of x is equals to kx plus 1 if x is less than or is equals to pi cos x if x is greater than. Okay, now we will check the left hand limit. Left hand limit, limit extends to I minus f of x. Okay, here we will roughly draw the function now. Okay, here at x is equals to pi, x is less than pi, and x is greater than. At x is equals to pi, the value kx plus pi. At x is less than pi, the value kx plus 1, and here cos x. Okay, now limit at x is equals to pi minus, what is the f of x? That is kx plus 1. Again, substitute x by pi, we get k pi plus 1. Now, right hand limit, limit extends to pi plus f of x. Okay, here limit extends to pi plus, at what point the function is cos x. Okay, substitute cos pi. What is the value of cos pi? Okay, the value of cos pi is equals to minus 1. The value cos pi is equals to minus 1. Now, the function. Now, the function can be defined. The function can be defined at x is equals to pi. Okay. Now, f of x is equals to limit x tends to pi. F of x. Okay. Here f of x is equals to, what is the value of f of x at kx plus 1, that is at x is equals to pi, the value k pi plus 1. Now, by the definition of continuity, we say the left hand limit x tends to pi minus f of x, and right hand limit x tends to pi plus f of x, and the main function limit x tends to pi are coincident at x is equals to pi. Then we say k pi plus 1 is equals to minus 1. K pi is equals to, take plus 1 on this side, it becomes minus 1. K pi is equals to minus 2. The value of k becomes minus 2 divided by 5. Therefore, the value of k is equals to minus 2 by 5. This is the solution of the given function. Okay. Now, move on the next question. The question number. Okay. Let's discuss the next question. Question number 6. Find the values of a and b such that the function defined by 5 if x is less than or is equals to 2, f of x is equals to ax plus b if 2 is less than x less than 10, and f of x is 21 if x is greater than or is equals to 10. When we can observe these functions, here they define at 2 points. Okay, here I will consider those 2 points. The first one point is, okay, here the first one point is at x is equals to, I can roughly take on the values here. At x is equals to 2, at x is equals to 2, the value is 5. At x is less than 2, okay, at x is less than 2, the value becomes 5. At x is greater than 2, okay, here x is greater than 2, the values becomes x plus b. Similarly, at x is equals to 10, okay, we will take the values at x is equals to 10, at x is less than 10, and x is greater than 10. Okay, here at x is less than 10, the function is ax plus b. At x is equals to 10, the function defined 21, and at x is greater than 0, the function is 21. Now we can solve here. Okay, here by observing the rough diagram, we can easily say the left hand limit and the main function has the same values. So I can written here limit x tends to 2 minus f of x. The left hand limit is equals to the right hand limit x tends to 2. F of x is equals to limit x tends to 2 minus f of x is 5. Here f of x is 5. Then the equation becomes 5. Similarly, I can solve here for RHS part, that is limit x tends to 2 plus. The function f of x is equals to limit x tends to 2 plus f of x becomes ax plus, again substitute the value, then the value becomes, that is the value is okay. Let's discuss the question number 6. Find the values of a and b such that the function defined by the function f of x is equals to 5 if x is less than or is equals to 2, f of x is equals to ax plus b if 2 is less than x less than 10, and f of x is 21 if x is greater than or is equals to 10 is continuous function. Okay, they already given the continuous function. Now we have to solve or find the values of a and b. First, here when observing the question, they given 2 points at x is equals to 2 and at x is equals to 10. Okay, now I can solve at x is equals to 2, then the function. The rough diagram I have here written here at x is equals to 2, then at x is less than 2, and x is greater than 2. Okay, here at x is equals to 2, the value becomes 5. At x is less than 5, then the function is 5. Here ax plus b. Now, while observing the rough diagram, we can say the function here x is equals to 2. Okay, so we say at x is equals to 2, f of 2 becomes 5. Then the left hand limit extends to 2 minus f of x. What is the value of f of x? That is limit extends to 2 minus, that is 5. Okay, here that is 5. RHL part. Limit extends to 2 plus. Then the function f of x is equal to limit extends to 2 plus of function. What is that? Ax plus b. Okay. Substituting the ax values here, then it becomes a in value. Okay. That is x value will be 2. Then we can say, okay, here I will take, that is 2 into a plus, okay, by the definition of continuous function, by the definition of continuous, we can say 2a plus b is equals to 5. That is equation number 1. Again, at point x is equals to 10. Okay, at x is less than 10 and x is greater than 10. At x is equals to 10, the value becomes 21. At greater less than 10, it becomes ax plus b and 21. Now again f of 10 becomes f of 10 is equals to 21. F of 10 is equals to 21. Then the left hand limit. Okay, the left hand limit extends to 10 minus f of x is equals to 4. Limit extends to 10 minus f of a into x plus b. Then substituting the values, it becomes 10a plus b. Okay, again. Okay, again the right hand limit extends to 10 plus f of x. What is that? limit x tends to 10 plus. What is the f of x? Here, the function f of x is 21. Then the value becomes 21. Again, we say that by the definition of continuous, function, we say 10a plus b is equals to 21. This is equation number 2. From equation 1 and 2, I will take here, that is 2a plus b is equals to 5 and 10a plus b is equals to 21. Now, I will subtract. Okay, then it becomes minus 10 minus 2, that is minus 8a, plus minus get cancelled. Here minus 21 plus 5, it becomes minus 16. A value becomes minus 16 by minus 8. 8 ones are 8 twos are. Then a value becomes, again solving the substituting a values in equation 1, that is 2 into 2 plus b is equals to 5. 2 twos are 4. Then we want b only. 5 minus 4 becomes 1. Therefore, we say a value becomes 2 and b value becomes, which is the solution of the given problem. Okay. Now, we will discuss the next one. Okay. The next one problem is question number 11. Okay. Find the value of k so that the function f of x is equals to 1 minus 2x divided by 1 minus cos x if x not equals to 0. Then the f of x is equals to k if x is equals to 0 is a continuous function. Okay. Here, the given function. Let us consider the function f of x is equals to 1 minus cos 2x divided by 1 minus cos x if x not equals to 0, and the value becomes k if x is equals to 0. Okay. Now, f of 0, because x is equals to 0 at point f of 0, k at x is equals to 0. Now, we check left hand limit. Limit x tends to, limit x tends to 0 minus f of x. What is the value of f of x? That is 1 minus cos 2x. Okay. Here 1 minus cos 2x is divided by 1 minus cos x. Okay. I will written here. That is 1 minus cos 2x divided by 1 minus cos x. When we apply 0 directly here, we get 0 by 0. We get 1 by 1, 0, and 1 by 1 will be 0. When we substitute the values, we get 0 by 0 form. So, I am using L'Hospital rule. By using L'Hospital rule. By using L'Hospital's rule, again, differentiate separately. X tends to 0 minus f of x. Okay, I will separate. 1 is constant minus differentiation of cos 2x. Otherwise, we can simply writing the formula. Okay. Now, let us consider the problem 11. Find the value of k so that the function f of x is equals to 1 minus cos 2x divided by 1 minus cos x when x is not equals to 0, f of x is equals to k if x is equals to 0 is a continuous function. Okay, let us solve the problem now. Okay, I can solve here. First, I will consider the function. Let us consider the function. Let us consider function. Okay, let's start. The question number 11. Find the value of k so that the function f of x is equals to 1 minus cos 2x divided by 1 minus cos x. When x is not equals to 0, then f of x is equals to k if x is equals to 0 is a continuous function. Okay. Now, let us solve the problem. Let us consider the problem or function f of x is equals to 1 minus cos 2x divided by 1 minus cos x, and another one point k. If x is not equals to 0, here x is equals to 0. I will define the function. Let at x is equals to 0, then f of 0 will be k. Now the left hand limit extends to 0 minus f of x. Okay, here I am writing the function at x tends to 0 minus f of x. 1 minus cos 2x divided by 1 minus cos x. Here, when I substitute 0 here, we get 0 by 0 form. That's why I am taking the simplest form. Okay, that is 0 by 0. I can return 1 minus cos 2x in the form of 2 into sine square x, because we know the formula. What are the cos 2x formulas? Cos 2x can be written as cos square x minus sine square x. Again, it can be written as 2 cos square x minus 1. Again, 1 minus 2 sine square x. So, I can replace 1 by cos 2x by 2 sine square x divided by, here also I can replace, because we don't have any cos x formula. I will divide x by 2. Then it becomes 2 into sine square x by 2, which is of the allied angle. Okay. Now 2 by 2. Okay. Here 2 by 2 get cancelled. 2 get cancelled. Then here 2 sine square x and 2 sine square x by 2. Then limit x tends to 0 minus, I will divide it by x square and multiply x square here. That is sine square x divided by x square, and I will multiply x square here, whole divided by, here I will divide sine square x by 2 and multiply x by 2, because we know the one of the standard limit x tends to 0, sine x divided by x is equals to 1. Okay, which is the standard formula. That's why I am taking x square and x square here, and x by 2. Then I applying the limit x tends to 0. It becomes sine square x divided by x square becomes 1. Then x square. Okay, then it is x square here, the value x square divided by Okay, x by 2 and x by sine square by x by 2 here. Okay, that is because we have sine square x. That is x square by, I will take these of the form x square on multiply 1 by x square in divided by 2 square will be 4 and here also 2 square. Okay, that is 2 square becomes 4. X get cancelled. X square get cancelled. Then 2 square will be 4. 1 divided by 1 by 4, it becomes 4. Okay. Similarly, the left hand limit becomes, okay, limit x tends to 0 minus f of x is equals to 4. Again, at x not equals to 0, then the right hand limit also same. X tends to 0 plus is also equals to 4. Again, by the definition, of continuity, by the definition of continuity, by the definition of continuity, we say k is equals to 4 because the value, the main function becomes x is equals to k, left hand limit and right hand limit value becomes 20. Therefore, the value of k becomes 4. Next, we will solve the next one problem. For what value of alpha is the function defined by f of x is equals to alpha of x square minus 2x if x is less than or is equals to 0, 4x plus 1 if x is greater than 0, is continuous at x is equals to 0. For what about the continuity at x is equals to 1? Okay, first we have to check the continuity at x is equals to 0. If it is continuous, then we check again continuity at x is equals to 1. Okay, now let us consider the function. Let us consider the function f of x is equals to alpha of x square minus 2x if x is less than or is equals to 0, then 4x plus 1 if x is greater than 0 is continuous. Now at x is equals to 0, then f of 0 will be alpha of x square minus 2x. Okay, here while substituting x in front of x by 0, we get 0. Again, we have left hand limit, x tends to 0 minus f of x. Substitute limit x tends to 0 minus, what is the f of x? Alpha of x square minus 2x. Again, substitute the values, we get 0. Then RHL limit x tends to 0 plus f of x. Okay, here limit x tends to 0 plus, what is the f of x? 4x plus 1 is equals to 1. Again, by the definition of continuity, by the definition of continuity, we say left hand limit x tends to 0 minus f of x, limit x tends to 0 plus f of x is equals to limit x tends to 0 f of x, limit f of x is equals to, okay, is not coincident. Okay, not coincident. Therefore, it is not continuous. It is not continuous at x is equals to 0 because the left hand limit, right hand limit and the function is not equals to 0. Okay. Then now at x is equals to 1. Here at x is equals to 1 means the value x is greater than 0. The limit exists at x is greater than 0. Therefore, the function limit x tends to 1 f of x is equals to limit x tends to 1. What is that function? 4x plus 1 while substituting the 4x. Okay, again 4 into 1 plus 1, it becomes 5. Okay, hence the function is continuous. Hence the function is hence define the hence we define the function. Okay, hence we define the function. Therefore, it is continuous at x is equals to 1. It is continuous at x is equals to 1. Then we will discuss the last one problem, that is define the continuity of function f of x at x is equals to c. Find all the points of discontinuity of f defined by f of x is equals to mod x minus mod x plus 1. Okay, this is the one of the important problem. Okay, now let a real function let a real function f is said to be a real function f is said to be continuous. A real function f is said to be continuous. A real function f is said to be continuous at x is equals to c if and only if we have the limit. First one, limit x tends to c. Okay, f of x is equals to c because which is the definition of continuity. We define f of x is equals to at x is equals to c. We already know that we already know that every modulus function is continuous. We know that every modulus function is continuous. Every modulus function is continuous. For every x is belongs to the real number. Okay, then f of x is equals to mod x plus minus of x plus 1 mod of x plus 1 is difference of two continuous function. Difference of two continuous function. Since mod x and mod x plus 1 are continuous everywhere. Continuous everywhere. And difference is also continuous. Difference is also continuous. Difference is also continuous. Hence, there is no point of discontinuity. There is no point of discontinuity. Okay, this is the proof. Up to this much, the concept will be